Now dear student, we are going to discuss question number 4.5, and in this question it is given to you, read each statement below carefully and state with reasons if it is true or false. Clear? We have to find which statement is true and which one is false. Now, number one statement is given to you, the magnitude of a vector is always a scalar. Yes, this statement is absolutely correct. Why? Because we know, let's suppose if I say to you velocity of an object is 20 meter per second and it is going in a north direction. Clear? So we know magnitude of velocity, it indicates speed. Clear? If I am talking about magnitude, means we can, if I am saying 20 meter per second, 20 meter per second is what? This is speed. So we can say magnitude of velocity is speed. Clear? So we can say magnitude of a vector is always a scalar. Yes, this statement is true. So I can say this is true. Clear to everyone? Yes. Now if we talk about each component of a vector is always a scalar. Clear? Each component of a vector is always a scalar? No, this is a false statement. Clear? We know if we talk about the component of a vector is also a vector. Clear? So we can say this statement we have false. Clear? Now if we talk about third statement, the total path length, it means we are talking about distance, is always equal to magnitude of the displacement vector of a particle. Again we have false statement. Let us try to understand this statement. Let's suppose this is my initial position and I am going in this direction. Clear? And I am not taking a U-turn. Clear? At that time what happened? At that time you can say that distance and the displacement both are same. Clear? But let's suppose situation now changes. I am going like this. I move up to this point and then I am taking here a U-turn, and let's suppose I come to this position. At that time you can say displacement is what? It is the minimum straight line distance between final position and the initial position. So we can say this is displacement. But what about total distance? Total distance, we can say total distance is the total length of a path that I am covering. Clear? So this is the total length. Clear? So it means we can say distance is not always equal to the displacement. Clear? So we can say total path length is always equal to magnitude of displacement? No. Clear? If a particle is not changing its direction, at that time we can say this is correct. But let's suppose particle changes direction, what will happen? At the time we can say displacement is not equal to distance. So again we can say this is also a false statement. Clear everyone? Yes. Now if we talk about part number D, average speed of a particle is either greater or equal to the magnitude of average velocity of a particle over the same interval of time. Clear? Now listen carefully. Average speed of a particle is either greater than or equal to. Correct? Because we know average speed is related to total distance and average velocity is related to total displacement. So definitely we can say distance, it may be greater than equal to displacement. Yes or no? We have already seen in the part number C. Distance, it may be greater than equal to displacement. So we can say average speed, it may be greater than or it may be equal to average velocity. Clear? So we can say this statement we have, this is true. Clear? Now we are going to discuss last statement. In this statement we have three vectors not lying in a plane can never add up to give a null vector. Definitely. Let's suppose if I am saying to you, let's suppose here we have a vector A, let's suppose here we have a vector B. Now let's suppose I am assuming these two vectors lie in a same plane, but let's suppose here we have a third vector like this, that is out of this screen. Clear? At that time if we add all these three vectors, definitely we can say here we will not find net value of net vector addition, that is 0. Clear? So if I say let's suppose this vector C is also in this same plane, then you can write like this, A vector plus B vector plus C vector, this should be equal to 0. Clear to you? But three vectors not lying in a plane, it can never add up to give a null vector. Yes, this statement is true. So we can say this is true. Clear? So I think all the 5 statement is clear to you. So this is all about this question. Clear?